Hi, my name's Andy. Welcome back to our mini Rust in Rust series. This is video 25. We are trying to make this little snippet of code. It's not a function because I can't do functions yet. Parse, elect and parse, and it eventually evaluate so that it can work out a factorial. I nearly said Fibonacci again, but yeah, factorial. So basically we create some variables. Some of them are mutable, which we're currently not really checking. And then we loop around doing this, repeating this bit of code again and again until a certain condition is matched, and then the answer is whatever's in X. So where we got to is we can understand all the code up to here, lexing and parsing it, and I guess evaluating it will just automatically work because so far this mute isn't doing anything. And we can't yet parse this bit because we don't actually know that while is a keyword, so we think we've just found a symbol and then the stuff after that doesn't make sense. So we need to be able to recognize that while is a keyword and then recognize that after that keyword this particular type of construction is expected, essentially an expression which evaluates to Boolean. And then we expect a curly bracket, and then we got a load of statements and expressions inside, and then a closed curly bracket. So I'm not sure how much we're going to get through of that today, but let's just start at the beginning. And if we unignore this test, this is like our guiding test, so it's not passing yet. When we run it, it says, I wasn't expecting this I, and that's because it doesn't understand that while is a keyword. So let us re-ignore that and get some lexing of keywords going and see how far that gets us. I don't need a micro break. So let's write a test that checks that the while keyword is understood to be a keyword. So here's our test for keywords. We're dumping them all in one test. I don't know if that's a good idea or not, but they seem such a simple idea that kind of makes sense to me. So we should find a keyword called while at the beginning, and it should be 5 characters long. Again, we really don't need this stuff, so maybe we get rid of it. And it's complaining, saying there's no keyword called while. So, oops, what on earth was that? So let's add a keyword called while. And will our test pass? No, because we haven't actually written the code that lexes things to understand what while is. Where is our function that checks whether a symbol, the thing that might be a symbol, is actually a keyword? Just search for the word let in quotes, as what I did before. Yeah, all right, there we go. So, like this. So this is the thing that whoops, what did I press? Yeah, just before we say, oh, this is a symbol, we just double check whether it's a keyword. And in this case, if it was while, that is a keyword. So now lexing keywords should work. Lexing while specifically as a keyword should work. So let's go back to our example, see what fails again. And it should say, I found a while, I have no idea what to do with a while. So now this is a parsing error, right? Before it was, well, it wasn't even a lexing error, it was a parsing error, right? But the problem was in the lexing because it thought that while was a symbol, so expected it just like equals or something after it. Or no, maybe not that, a plus or something like that after it. Now it knows that while is a keyword token, and the parser doesn't know what to do when it sees while at the beginning. So let's write a parsing test that checks we know how to deal with a while loop. Now, what while loop shall we write that is simple but also not nonsensical? Let's make a test that's a bit like this, that's after all of our assignment tests. Yeah. And let's call it parse a while loop. And I think we should probably make this test check that the whole of a while loop parses, so it's still going to fail. What's the simplest but not crazy while loop. I guess it would be while 1 is less than 2, do nothing. That's probably the simplest we could imagine. So this should be a while loop, so I'll just call that a while, I guess. And inside that while loop, it's going to have, I'm making this up as I go, but I think it's going to have an expression. So that would be syntax tree. Oh no, it won't be just any expression. It will be an operation in this case. So in general, it will be an expression, but in this case, it's an operation. And the operator will be less than, oh gosh, we don't have less than yet. Let's do less than or equal. The operation consists of an operator token of type less than or equal. I didn't seem to, hold on. Operation takes in an operator token. And I've only written a helper function for plus, so I need another helper function. Let's make that. And this is going to be less than or equals, I think the S is right, an operator token kind of, what operator token kind of, alright, so somehow I've missed out. When I wrote support for operator, for this type of operator, I didn't add this, I didn't end up needing to add it into the operator token kind list. So I must have missed something somewhere in what I was testing. Less than or equals. Like so. Now we're going to get a few errors. Okay, the reason why is because we haven't actually done any evaluation of that less than or equal operator. We've made it parse, but we haven't actually made it evaluate yet. So by doing this parsing, yeah, I guess the point is we've got other errors. In our example case, we've got other errors that are stopping us from getting to this. So this is good. This is good. It's pushing us to implement evaluation of less than or equal operator, but we can put a to-do in for now. Like so. Because we'll get to that eventually. Let's see what else is broken. All right, so it's we haven't got, yeah, this is kind of half written code. So let's finish writing this code to see where we get to. So it's going to be the operator token less than or equals. It's going to contain less than or equals, and the span is going to be what are we passing for a span? Yeah, just a pair of U sizes. The span is going to be from 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, and it's too long. So that is just the operator token, and it's going to be between two expressions, which are both actually going to be let's just put nothing there for a second. And that's the end. It's just a while. We don't know what while takes in, but it's definitely going to take in a list of like commands that happen inside. But this is, in this case, it's going to be an empty list. So there's no function called while. So obviously a lot of this doesn't work out very well. And these should be boxed syntax trees. Yeah, so on the left-hand side of the... So I feel like we should be parsing less than or equal. Yeah, what's gone wrong here is that this parse while is doing too many things, because somehow we've managed to not write a test for parsing a less than or equal expression. Yeah, we've only done lexing on less than or equal, so let's do that first. Let's take an example of parsing just something plus something. Like this. We'll do that parsing a while in a second, but first let's parse a comparison, let's say, produces. What did I say in that test I'm copying? Produces an operator expression, that's probably fair enough. Produces, and it's actually an operation expression, so let's get it right here. Doesn't matter too much. Let's imagine we're saying 28 is less than or equal to 1. Oh no, we always change it, right? So it's going to be an operator token less than or equals, like this. It's going to go from 3, 2 symbols along. This is going to be 28. This is going to move along one more because our operator is wider. Now, that parsing will currently fail, right? Hold on. Our example's failing. Let's just ignore our example again. And check we can parse this less than or equal expression. So it's an operation with an operator token of kind plus. Yeah, so that's where we've gone wrong. So where does that parsing happen? And we're looking for less than or equal. Problem is, the parsing doesn't check what operator type it is at all. It just says, look, there's an operation. Hang on, we've been given an operator token that's already the wrong type. I think that's what's happening. So I think the bug is in our lexer, right? Let's have a look at where we deal with less than or equal in our lexer. Yeah, we call the operator function, and the operator returns a token kind operator. Where does that plus get done? Where does the plus get done? We've missed something out here in our parser. Is it here? I think we're calling the wrong. Right, yeah. When we turn an operator token into an no, so when we turn a token into an operator token, we don't check its kind by looking at its literal, I guess would be the way to do it. So I think it's here. So how do we test this? We're in the parser. I guess we're testing it right now. We're testing it right now, so it's fine. So based on this value, which is a token, value has a span and a kind. So what we could do is take the literal and decide based on that, but we're trying to get rid of these literals. So I might prefer to match on the span, or rather the span. Oh gosh! All right, let's not do it now. All right, so this is a reason to have these literals, which I don't like. We're going to fix it, but not now. So we're going to match on the literal, and if it is plus, we're going to do this, and if it is less than or equal, we're going to do something else. And then we're going to end. And it's matching stress. So if we do .deref on it like we did on the couple of videos ago, it should now give us 2deref, sorry. That gives us an ampersand, which is what we're looking for, right? Literal is a string. Should be asdref. Astra will do, fine. Astra is actually better for what we want. And yet we haven't covered all the cases. So if it's an unknown type of operator, then we need to return some kind of error. Is it that it's not an operator token? I mean, it's an unknown operator. We just should never get here. We should never get here. So we could just crash here, or we could say it's like an unknown operator token. So we could change this to be, I think this is okay. It's basically saying this should never happen. So this, no, it's different. It's different. This time it's saying try and make it. This is a totally different error. So let's not make it the same thing at all. Let's make this be an enum and rename it to, no, what is it? Press. This should be it's an error turning a, where does this get used? This gets used, where do we call, let's have a search for try from. I'm going to mark this place as, and I can't come back to it, otherwise I'm going to really lose myself. And somewhere I saw that we were using try from to make a token out of a thing. This is it. Yeah, check token of type. Was that the only place? And if it fails, we want to say unexpected token. But in our case, we've got another type of error. I'm not even sure this is the right. Yeah, this is not the right try from. I don't think. Maybe it is. Let's have a look at where that, we'll go back to our bookmark. Let's have a look at where operator token, or not operator token, is used. Here. No, that's where it's returned. It's not explicitly used anywhere, but where is this try from? Okay, let's just delete our try from and see what code fails to compile. And that should help us. Because here, yeah, it's here. When we're trying to create an operator token from a thing that we think might be an operator, okay, and we know that it must be an operation at this point. It must be an operator. So we know we're expecting an operator. So anything that's not an operator or not a known operator is an error. Okay, so that's good. So all right. So let's go back to where we were, and we can just say there's two different ways this can fail. Either it wasn't an operator, or it was an unknown operator. Converting to operator failed. Or treating as operator failed. Or no. What was it called before? Not an operator. I guess not an operator token is right. Yeah, not an operator token is right. There's just two possibilities here. Either incorrect token type, or this thing, which is unknown operator literal. It doesn't have to be too good an error message, because This should never happen. Let's just say that should, and let's put a comment before it. Should never happen. Should never happen indicates that the lexer thought this was an operator, but the parser doesn't recognize it. Please make my comments look nicer. Oh, I can do cargo plus nightly formats, right? And that'll make it look better, please. No, because I haven't turned on it. Okay, I need to update my Rust format to make that work. All right, so that means now this is not an operator token, : incorrect token type, right? I mean, maybe it should be incorrect token kind, to be clear that we don't recognize the kind. And this is not operator token. Unknown operator literal, because the literal was not something we recognize. Should never happen. I think we're there. It's moaning that we never use it, but we never use that string. And why don't we actually... This is not one. This is not this error, right? This thing is just totally dumb. So I would like it to be a this error, and then I guess I would like to explain what it is here, and then we could provide more explanation here and. Yeah, I'm keen on making error messages good, so I'm going to push through and make this happen, right? What's it moaning about? Doesn't implement display. What if I put this in? And how are we going to explain this? And it is kind of unexpected token. Problem is, this is the error that actually does the work here. And so I think this is just a little thing, and we shouldn't say, like, basically, like I said, this should never happen. So, let's not get too detailed about what went wrong. Like, the fact that this happened at all will lead us to this line of code, which says should never happen. We should be okay, hopefully. All right, so what's it moaning about? Never construct a less than or equals. We'll get there. Okay, so where are we at? I'm a bit lost. Okay, we hit a to-do. I was worried it was complaining about threads here. But okay, yeah, the thread panicked, saying not yet implemented at 465 because we left a to-do in here, which was, if you find a less than or equal, you should return something a bit like this, but not the same, which was our problem before. I've left another to do somewhere else, I remember. So the operator token kind should be less than or equal. So it's weird that all this stuff was missing, but it's because we're being driven by our example, and our example, like, it tries to lex the whole of our example before it tries to parse and then evaluate the whole of our example. So we got a little bit far down like a path without actually fully implementing less than or equal. I think that's what happened to us. So now we've created a less than or equals when we find less than or equals. So now our test for parsing a less than or equal expression is looking better. So we've got an operator with a less than or equal span of 3, 2, and then this is all looking the same. Oh, look. I think it's just that we got the number wrong in our test. So let's have a look at that. Yeah, we said 7 and there's a 1 here. So hopefully now our less than or equal expression parses. Yes, it does. And it parses into something sensible looking. So now let's get back onto parsing our while, which is not yet ready to parse. And it should consist of a while, which itself consists of an operation of basically something that looks like this. Something like that. Let's see if I got the right commas in the right places. No. I'm definitely missing some brackets. Another one there. And then that one matches up with that one. Missing comma there. And now our main complaint is there's no such thing as a while syntax tree. So I think this test now looks approximately how it should look, except it should work. So just like there's an operation function on syntax tree, there should be a while function. A bit like assignment, a lot like assignment. It's going to be, because assignment starts with let and while starts with while. So while is going to consist of, what did I say in the code I just wrote? I said oh, this is wrong. Is it? No, yeah, I'm looking in the wrong place. Yeah, it should be a while. A while should consist of an operation, which is what this is. Oh, come on, please format this nicer. Oh, it's complaining that while doesn't exist. It should consist of an operation and a list of statements. And I think that might be it. So let's go here. It should consist of an operation, which is going to be an expression. Oh, yeah, it should be an expression. Exactly like that. And then a list of statement or list of statements or expressions. Like, I think we should call this condition expression, and maybe this should be, I don't know whether this should be a list of statement or an expression itself. So let's just call it body and not the other stuff. And body should be some kind of like to do, like we don't actually know yet. I don't want to think about that yet to get this test passing. So it maybe is a list of expression, it maybe is an expression, or maybe I think it's actually bumping up against the fact that we don't know yet. So let's ignore it, let's remove it. And let's say there is a type of syntax node called a while, and at the moment all it takes is a condition expression and nothing else. And that should exist, so let's make it. And condition expression is going to be a box of T. This is the syntax node abstraction we made that means that both typed and untyped syntax trees can use the same type. That's why there's a T here. So this would be, in our case we're looking at now, this would be a condition expression which is a box of syntax tree as opposed to a typed syntax tree. If that means nothing to you, ignore it. That's from a couple of videos ago. So now we can't call it while because while is a keyword. So we could call it while underscore. And then the code that calls this is also going to need to call it using while underscore, which is why the code formatting was so confused. And we'll only pass in one argument for now. We need some kind of to do. This should be a box wrapping that thing up because that's what it is. And let me just put a to do in. This should also contain the code that lives inside the while loop. Something like that. Oops. All right, let's try running our tests. And we've got a few compile errors. So first of all, everywhere where we do something, so in the evaluator, when we have a while loop, we need to like do something with it. And for now, we're just going to do this away. Like so. We can leave that warning in, I think. And also, when we're type checking, we need to do something with a while. We'll leave that warning in too. And another place where we're type checking. And again, we'll just have a to do. And there's a few other things that we're not type checking either, it looks like. In a span. What else? More type checking. This time we're type checking. We're printing out. It's like there was a type check error, so we're printing out like where we were. It's going to be if that was a while statement, then we haven't yet written any code to format that nicely. Now there's just warnings. Now hopefully we'll at least get some kind of test failure, right? Yeah, so we got a test failure saying we don't know how to parse a while loop. Right, so we're getting somewhere, So when we're parsing at the moment, first thing we look for, I think, is no, at least when we're parsing an expression. Yeah, okay. When we're parsing an expression, which could be a statement or not, right? Oh, no, it's the inside of a statement, kind of before the semicolon. Then it could be a let, and now we're saying it also could be a while. And if so, we're going to call, instead of calling an assignment, we're going to call a new function called while. And the things that might end a while statement are, well, no, not the things that might end a while statement. The things that might end our expression prematurely are the things that end this expression, I guess. Is that even right? We'll check that out in a minute. And that can't be called while. It has to be called while underscore. And there's no function called while underscore, so let's make one. It's going to look a bit like assignment. But assignment is super complex, so let's not copy it. Let's first do something really simple. Like just nothing. So if we make this here, let's put it... Okay, it can go after assignment. I think that's okay. Fine. And what we need to do to parse a while statement is to first look for an expression, and then look for a brace, and then some stuff, and then a brace. So for now, we'll just look for an expression, and then brace. So where do we look for expressions? I think we can just call self.expression. Is that a thing? Yeah, I could have sworn. Yeah, expression is a method. I'm somehow not getting auto-completion on it. So this should be condition. Condition expression is self.expression. I think that's okay. What does that take in? All right, stop moaning. Should return a syntax tree. All right, we're going to make a syntax tree in a minute. Don't get picky with me. So we're going to return a syntax tree of type while containing condition expression. Right. So we're okay so far. Tell me what expression takes. Why are you being so mean to me? What does expression take? It takes in just end markers. So we'll pass in those end markers unmodified, and we'll think later about whether that actually is right or not. Now, expression might fail. So I guess we question mark that. And we can't question mark it because it's an option of a result. Is that right? Expression returns an option of results. So if there's no expression there, then we fail in one way. So let's just deal with the case where there isn't one, like this. By just returning early if not. Now there always needs to be, so this is actually an error. Saying like we expected an expression. Missing expression, I guess. What does missing expression do? Yeah, we expected an expression here, and there wasn't one. I guess that's fine. Where else do we create a missing expression? Let's copy. Quite nearby, so hopefully that's okay. Hang on. Condition expression. Oh, I'm really... My code completion has got confused, I think. Or I am really confused, or both. So, condition expression is an option of a result. So if it's missing, then we're going to fail and say there should have been an expression here and there wasn't. And this shouldn't be symbol. This should be I guess we should be passing into while some kind of like where are we now. I guess. Oh no, am I thinking of the Alexa? I think I'm thinking of the Alexa. So what is symbol here? It should be well, where is symbol? Why does it think it's okay? No, it doesn't. Right, fine. So condition expression is not a struct variant or union type. All right, I'm still getting funny compile errors. Let's run the compile on the command line and see if we get any better. Oh, is it just that I call? Yeah, okay. It's just that I called the function a name that's not allowed. So now things are really confused. All right. So now is it better? Yeah. Condition expression is an option. Therefore, I should be able to say, let some condition expression. Oh, hang on. Okay. I missed a keyword, let's say. And yeah, when we return this error type, we have to call .into on it. And now we've finally got the thing I was expecting to get, which is like, I don't know what you're talking about, mate. I haven't got a span that I'm working with. So we could pass in the span of the thing that we found here. This keyword. Does that have a span? The token should have a span, I think. Does the token have a span? Yeah. All right. So let's go for, what am I going to call this? Shouldn't call it span. Should call it, let's call it keyword span for now. It's the while keyword span, but that's okay. So now we can just pass in. I think that it's looking for like a place to say where this error happened. And I think basically immediately after this keyword is the best we can do here. So we expect an expression after this keyword. Obviously, we can't say where that expression was because it didn't exist. All right, so now we've got a condition expression. Now we can call while. Now we need to question mark this, and we need to wrap it in a box, like so. And finally, we haven't used token. What was token? Oh, hold on. I think token was the token we were dealing with. So I think I could have just said token.span like that. I didn't need to. Yeah, all right. So I was being silly. We were already passing in the token. Yeah, you can see now. Right, fine. So when we hit a while, we expect to get an expression. If we didn't get an expression, it's an error. And then later we will find statements within while loop. Now this isn't going to work because we haven't done the braces yet. So let's see how far we do get. Fix those warnings soon. And it says, yeah, I didn't expect a brace here. So let's make it work with that first. So we can expect a brace by saying self dot token of type. So we have to say what type, which was it was a what is it expecting? Token of type returns a T, where T is something that can be try-frommed a token. So this should be a operator token. Kind? No, that's not right. It's a separate type called like a brace token, which we don't have yet. So maybe this is wrong because we don't need a brace open token type. So instead, I think we just get a type. I mean, get a token by calling self.token. Now, what does self.token take in? It takes in the previous token span, which we can do. And it should be of type. It should be a open brace. What type does that have now? It has a type token. So we need to just say, if it's not, maybe we match it. We could say if not matches. What do you pass into matches? If brace open doesn't match token with a kind of. So I guess we could say if the kind doesn't match the thing we want, that'll be easier, right? Then it would be token kind brace open. Then this is going to be an error. Oh, I guess it's some kind of unexpected token. And where else have we used an unexpected token that I can just copy from? Here's one example. So how much of this stuff's right? This should be token.span. And this should be turning it into a string, I guess. Why is there no toString when I thought I'd implemented toString on tokens? And we need to call it into again. Oh, we can't turn tokens into strings. What have I done elsewhere with this? Come on. Oh yeah, we've looked it up using the span. And here we did that earlier in some way, right? Where does token struct come from? Here. Right, let's look at the place where we did it inline and do the same. It's a bit odd, this. Like I feel like I'm missing something here, but it'll do us for now. Am I actually... Yeah, I'm using the wrong token here. This should be the brace open token. And brace open here. And dot span. I mean, this is awful, isn't it? We can fix it once we've got it actually vaguely working. All right, so let's just do it here. Well, at this point, we know that we need to work this stuff out. So token str is all of this stuff. We can do the to end here as well, probably, and then we can just say. It's just shortening. We're just shortening the code a bit to say it's just made out of span instead of brace open dot span and all that. Semicolon there. And now this should be span dot into and token str. Like that. And somehow I added a semicolon in there, which is not right. So basically we're saying find me an open brace. And if it's not an open brace, it's an error. I mean, that's a really verbose way of saying that. And now we've got to find a closing brace. And if we could find a nicer way of saying this stuff, I would be happy. So this should be brace close. And its kind should be brace close. And everything in here should be mentioning brace close instead of brace open. Then maybe our test will pass. Close, so close. All right, let's have a quick look back. We were very quick with this bit of code here. So we looked for the closing brace. We made up all the stuff if it goes wrong. If it is a closing brace, we do nothing. But if it isn't, that's when we end up in this thing. I guess we definitely need some error handling for this, which we'll get to. But it looks okay. I really don't like how verbose the error handling is. But there you go. Now, what's failing? It's our parse while test still. And it's failing because one of our spans looks different and stuff like that. So that's doable, isn't it? So let's have a look at where that test is. So it's saying while 1 is less than or equal to 2. And the positions of these are wrong. So this should be 0, 1, 2, 3, 4, 5, 6 for one character. And this should be 7, 8, 9, 10, 11. 11 for one character. Oops, not there. So is it as simple as that? It is. So we got a load of warnings because we've missed out a load of stuff that we should have done. But we have successfully managed to parse a step on the way to our example, which is a partial while statement with an empty body. And it feels like we've done plenty for this video. So next time we will continue with trying to make this example work, which I guess is going to be getting the body of the while to kind of lex and parse okay. And then we'll think about how this stuff actually evaluates. And particularly the while loop is going to need some cleverness to evaluate it. So I hope you enjoyed, and see you next time.